Okay, good afternoon, everyone. My name is Hansen Wang, from Aqrose. Actually, Aqrose is a company from China, the headquarters in Beijing. But we just newly registered our office in Berlin. So right now we are GmbH right now. So I'm really looking forward to do some business here in Europe. And the topic today for me is around the challenging AI application in the battery inspection. The EV battery right now is a very hot topic. So how to use AI to solve some challenging topics, pain points in this industry is what I'm going to talk about today. Yeah. Since Aqrose, we are newly registered here in Europe. So first of all, I would like to introduce a little bit more about the company. For us, Aqrose, we were established in 2017, so this is kind of the 7th year for us. After the establishment, basically we're focusing on solving some very challenging inspection tasks within the industry-wide. And for us, we are able to provide some standard AI software. At the same time, for some special key account, we are able to provide the turnkey software solution or the vision solution for our customers to do some customization. And the industry-wise, the consumer electronic, it contributes around 40% of our revenue. The EV battery, it contributes around 20% of our revenue. And the EV battery is what I'm going to talk about later. Just a summary. Right now we have around 450 employees globally, and more than 14,000 of our AI licenses have been sold across 800-ish factories, directly, indirectly. They are stably performed within the factories. So right now it's a time to go to the EV battery. During the EV battery cell manufacture, there are three main manufacture stages. The first one is about the electrode manufacturing. After the coating, the calibering, and the slitting, basically the visual inspection with AI is essential to it. There are a lot of factories, machines doing this. And the second one is about the cell assembly industry. For this, there are the notching, stacking, tap welding, can insertion, and also the other two processes. Basically, after notching, stacking, the welding, insertion, visual inspection with AI is required. And the last one, about the formation. And today I'm going to talk about the last one of end-of-line inspection. And this is one of the most important stations and one of the most challenging stations with AI. Yeah. For the EV battery, just in general, the pain points. The first one, of course, there are so many defects on the EV battery. And if you miss any kind of defect, it might cause fire or explosion. So usually the acceptance is very strict. They have to achieve 0% escape for many critical defects. The second one is about the inspection speed. For example, with the coating and calendering, the basic speed is around 6 meters per minute. And the medium speed is around 120 meters per minute. And the maximum right now we have tested is around 180 meters per minute. These have a very high requirements on the software or the algorithm performance. And also, for the cylindrical cell battery, the end-of-line inspection, it has to reach around 300 pieces per minute. And this is also a very high speed. The third one, of course, it's not limited to the EV battery. I think it's something in general, the shortage of the data. And you have to solve it to shorten the data collection period. And the last one is about the scale-up cost. Right now, I think many companies, they have done a lot of POC, but it's very difficult to make money with AI. Because for one model, you have to cover all these kind of shapes, models, colors, sizes. And sometimes, the AI model, they just the generalization is not so good, and the cost is very high. So, yeah, we are going to talk a little bit more about for this end-of-line inspection, how that four challenges look like. The pictures on the left side is kind of what a standard prismatic battery with blue film looks like. Usually for the inspection of this kind of end of line, it has to inspect all the 6 surfaces, like top, this is like the top, bottom, front, back, left side, right side, these 6 surfaces. And also on the lead, like the terminals, the injection hole, the vent, the QR code also has been inspected. Especially, those kind of edges, corners is also something we have to inspect, just in case, just make sure that no defects of bad quality will run to the next station. And the inspection speed for this is around 24 pieces per minute. And critical defects, those defects we have around 5 defects. For this, if you miss the inspection of this kind of defects, it's like the function-related or the security-related defects. And there are around more than 50 types of defects for the normal defects, like some small scratches, bubble particle, etc. For this kind of normal defects, usually they are able to accept a certain percentage of the escape. So the general target, 0% for the critical defects, and for the normal defects, they can accept around 0.2% to 0.3%. And for the overkill rate, from factories to factories, from models to models, they can accept around 2 to 5% of the overkill rate. And apart all of this, for any kind of machine builder or system integrator, they have to make sure that one system, they are able to cover several different models. So for this, the system have to be able to cover the different size of this kind of prismatic battery and the film color. All the projects we have tested, they have the black film, they have the blue film, which is the most popular one. We also have the green film, golden film, silver film. The black one is very difficult. Right now, we still don't have a very good solution for the black film. But for the blue film, green film, golden, silver, it's something under control. And also, the layout of this kind of the lead, the sequence is different. Something of it might be missing in different companies. And the film coverage, for some models, the blue film, they cover all of the surface. But some of them, they will maybe, the bottom side, it only cover part of the surface. So also, we need to cover it. And the shape of the vent, it can be oval. It can be this kind of rectangular and terminal shape as well. They have different shapes. The vision system, also the software, they have to be able to cover different kind of situations to make sure that the scale-up cost is under control. Yeah. So for the end-of-line inspection in general, despite more than 50 types of defects, and sometimes the image quality is not so stable, is not so consistent, and you have to achieve 0% critical defect escape, 0.2 for the normal defects, and 3% overkill. And for the speed, the 3rd generation of our vision system, there are 12 cameras, including 2D cameras and 3D cameras. And we have to process around more than 20 images within 2.5 seconds, including get the data, process, and give out the final results. This is also a very big challenge. The third one is for the end-of-line inspection, the overall yield is more than 95% usually for a factory. And for our AI model, it takes 3 to 50 images to build the initial model. And there are some defects, the long-tail defects, such as one of the critical one, the vent contamination. Basically, per each line, we can collect around 10 NG samples of this type within 1 month. So it means if we want to collect 30 to 50 NG samples for this, it will take around 3 to 5 months. That's unacceptable for many factories. This is very time-consuming. The last one is about the scale-up cost. Until right now, we have done 3 generations of the POC test. And basically, each generation of the POC test, it takes around 5 engineers for 6 months to finish all the process and achieve the final target. This is very expensive to do this, and this is very highly know-how based. So our software, our algorithm or solution, we have to be able to totally solve or partly solve these kind of like 4 problems to make this solution accessible by the customer. The first one is about of course, is about the AI network. Then we have done like some special optimization on 3 aspects. The first one is like the cross-layer connections, and also the second and the third is about some like unsampling, upsampling, and the resampling technology to make sure like the neural network they are able to detect the defects with higher resolution and with faster inference speed to make sure achieve those kind of very strict standards and to process all the data within 2.5 seconds to make it possible. I'll give some examples. The first one is about one of the critical defects. For example, with the blue film damage, usually like the general standard for this defect is like the size larger than 0.3 square millimeter. They have to be detected as a defect. And usually the third generation of the vision system, the pixel resolution is around 0.04 millimeter per pixel. And we need to do some mathematics here, and it contributes around like 187 pixels. So for our algorithm, since the accuracy is a little bit higher, so the real edge we output is closer to the actual value, actual size of the defects. So it means when we set the final standard, like the size larger than 0.3 square meter, it's a real defect. This value is more trustworthy output by our software. The second one is about the GPU. What kind of GPU do you have? Or do you need to use? For the third generation of the system, like 12 2D line scan images and 5 2D area scan images and 3 3D images are taken for the whole system. And within this, we use like 2 RTX 3090 to process all the data within like 2.5 seconds, and with the help of our customized like defect net neural network. Then the last one is even for the same defect, for example, like foreign matter, when we do the project, there's a difference between the soft foreign matter and the hard foreign matter, and they have different standards. And even for the same defect, for example, the soft foreign matter, the real standard on the front and back, left side and right side, and the bottom, and the height tolerance is different. So this is very know-how based, and our network, they are able to support this kind of multi-tag classification and to set those kind of very complex rules within the software, set different kind of filters. This is about the network. The second thing is about the data shortage thing. We have our AI defect generation tools, and on the part is some real engine data, and the second is about some generated data with our software. So basically, we are able to enlarge the training set around 30% to make sure the performance of the model is more robust. The second one is the data collection period. Right now, for example, you have collected 20 real engine data, and you can use the software to generate another 10 engine data. So altogether, the other 10 engine data, you can save this kind of time, more than 50% of the time saving during collection period. The last one is we have made the comparison. For one project, we only use 20 real engine data. The other one, we use 20 real engine data and 15 generated data. And we compare the performance of these two models, and it can achieve around 30–35% more accurate for the initial model to make it to deploy in the real application case. And the last one is about some scale-up tools. Of course, the AIDG, as I mentioned, and the image tuner to make sure the different copy lines, they have very similar image effects. So one model developed for one line, they are able to cover the rest of the other copy lines. And the private server within the factory, they are able to realize some data central management. And also, if there's one new model update, then with one click, you are able to deploy all the new models across lines. And with the AIDG and others, we also have collect some like defect library. For example, in this end-of-line inspection, we have collect this kind of like defect library, like on the terminal, this kind of like stains or dirt. We are able to use the defect library to generate the model. You don't have to collect more NG samples anymore for this. These kind of data are generated with our AI software. So as a result, from like data collection, training, optimization, right now it takes around like 1 to 2 engineers for 1 month to finish all the scale up period for one machine. This is a huge save. That was kind of like the general information. Then the last page is to introduce a little bit more fun application cases to combine AI with other technology, including with a programmable light for the crack inspection, and to combine with 2.5D, 3D imaging system, some welding inspection, and also some very high-speed and image taken and stitching system, and also to combine with the X-ray. That's also some other interesting cases in the EV battery. Yeah, this is about my presentation, and our booth is at Hall 8, B50, right over there. Like you can just drop me an email or stop by at our booth to get to know a little bit more information. Please scan me. Yeah.
Yongsheng, thank you very much. That was very interesting. Before I ask a couple of questions, are there any questions on the floor that people would like to ask? So obviously battery inspection's a hot topic in this new era. Is that where most of your AI is used, in the battery inspection, or is it a small percentage?
Because like we have like the consumer electronics, like it contributes around like 40% of our revenue. Right. And the EV battery, like it contributes around 20% of revenue, but it's increasing a lot. And we noticed a huge trend because in the past we were doing the business in mainland China, and right now a lot of like local European companies and some Tesla American companies, and they are building factories like in Europe, in the USA. So they, because they start a little bit late, so like right now they are looking for this kind of solution to help them to improve the manufacture like process, the yield rate, to help them.
Okay, and I saw that you obviously use a lot of different technologies, 3D, 2D, 1D. Do you design the setup of the camera technology, or is that your customers' expertise?
For us, you know, we have the special advantage as software and algorithm. So for this, some of them we will cooperate with some like machine builder or system integrator to customize some light or to design the system together. Okay. Because you know it's a combination between the hardware mechanical system with the software. Yeah. We need to adjust our in accordance with each other.
So a lot of your business, half of it is the core AI,
yes,
and the other half is the optimizing, customization, yes, for the application.
Yes,
okay.
Exactly.
Thank you very much.